Hello class, this is your next YouTube sensation, Mrs. Mathers, here to talk about important design controls. Actually, my YouTube channel has now been upgraded to preferred status. I guess there is some other teacher out there who actually likes my videos. I'm really sorry to have to be doing this for you today, but here we go, important design controls. When we are working with a experiment or any kind of research study, as I mentioned before, we must be careful to have good, specific, and consistent operational definitions. The example I talked about in class was ACT scores and correlation with college success. What does that mean? What is college success? College success could be measured a number of ways. It could be GPA. It could be employment at the end of college. It could be satisfaction with college life. It could be the matriculation rate. In other words, how many people graduate in 4 years. So remember that operational definitions, we have to say how we're going to be measuring our variables. Next, we need to choose a random sample from the subject population to make sure that we get a representative sample. So what this means then is that if I am doing a study on people with test anxiety and I want to find a new medication to help them get through test anxiety, then everybody has to have test anxiety. That's my subject population, and I choose randomly from that so that they do represent the population as a whole. Now, this does two things for us. It avoids sampling bias, and it allows us to generalize to larger populations. So if I did a study with 60 students who had test anxiety, had a control group of 30 students and an experimental group of 30 students, and I had a good random sample from the subject population, then I could generalize or say into larger populations, yes, this drug is effective for test anxiety. Number 3, random assignment to groups. This minimizes individual differences between groups. Students often have a hard time with this one. Let's just say that it makes it so that the groups are basically equal. So again, if I was doing a study on test anxiety and a medication to help with that, if I have random assignment, then we can assume that both groups are essentially the same. We must control extraneous variables to avoid confounding of variables. Let's say I'm doing the same study on people with test anxiety, and I test the control group in the morning and the experimental group in the afternoon. That's going to be an extraneous variable. People might react differently to tests depending on the time of day. Number 4, minimize participant bias. We can do this by, first of all, disguising the true nature of the research, which is something that many researchers will do. In the studies that you're going to look at in the next couple of days, that is indeed the case. They disguise the true nature of the research. Use a placebo for the control group. So if I was doing a medication for test anxiety, I would give a pill that looks very much like the actual medication so that someone would not know whether or not they were getting the treatment or not. And then use a single blind study. This means that only the participant doesn't know if they're in the control group or the experimental group. But if I were the researcher, I would still know. Now, how can we eliminate that bias? Well, we can then use a double-blind study. So minimize experimenter bias by using a double-blind study. That means the researcher and the participants do not know what group they're in, and a third party will take the data, analyze it, and give it to the lead researcher. And finally, use inferential statistics to determine statistical significance. If p is less than 5/100ths, then the probability that the differences between the control group and the experimental group are not due to chance. So we want to see enough of a difference between the two groups in order to make a conclusion. Now, I have talked very, very rapidly. Your teacher, who's ever here with you today, can leave these notes up. What I'd like you to do is get out this. Remember this? Okay, it says experimental design worksheet. Yesterday we did research methods, okay? Today, I would like you to spend the remainder of the hour working on these problems and looking for the independent and dependent variable, looking for problems with the experimental design, and take a look at all of these notes here and just determine what problems there are with each of these studies. So whether it's they didn't have a good representative sample or whatever the case may be. Please know that you can email me with any questions, and also the test will continue to be on Friday, and just, have a great time. All right, signing off. Goodbye.